So our next couple of lessons are going to be about solving exponential equations. Today versus the next one that we're going to look at is no calculator versus calculator. Okay, so I want to talk first of all really quick about what the difference is. So the way that you tell the difference is that if you look at all of these problems here, you're going to notice that they either have the same base number, like those are both base 3, or they can be written as the same base number. Like you can write 4 as 2 squared, and then they both have a base 2. This guy you can write as 2 to the third and 2 to the second. This guy is 5 squared and 5 to the third, right? So these can all be written as the same base number. Versus when you look at these guys, 5 and 18, you can't write those as the same base number, right? 4 and 12, 4 is a power of 2, but 12 is not. Okay, so that is the difference between the two types. If you can rewrite them as the same base, way easier to solve than if you have to do it the other way with the calculator. Okay, so if you can rewrite exponential expressions with a common base, you don't need logarithms or a calculator to solve. Okay, if you can't do that, that's when you need logs and a calculator. All right, and our basic property that we're going to use here is just that if b to the x equals b to the y, then x equals y. All right, and that is a property that should hopefully be kind of obvious to you, right? Because if you know that 2 to the x power equals 2 to the 5th, well, 2 to what power equals 2 to the 5th? Obviously 5, right? Obviously x has to equal 5 to make those two things equal to each other, right? That's all that property is saying. Okay, so what we're going to do is using that property here, because these have the same base, I know that this has to equal this. Those exponents have to be equal to each other. Okay, so x minus 1 has to equal 2x. And then we have a little baby solve that you know how to do, right? Subtract the x from both sides, you're done. And there we go. All right, next guy here. So this one, we're going to start by rewriting these as powers of the same thing. So 4, I can rewrite as 2 squared to the x plus 2, right? So then what we're saying is that product property here, right, of exponents, or power to power property, excuse me, says that I can multiply those together, and that's going to have to equal to this. Okay, when you do multiply that together, though, you're multiplying 2 times the quantity x plus 2. So make sure you do a distributive property. Okay, and I don't necessarily expect you to write this middle step out, but just make sure that you do that distributing. All right, and then from there, that's a pretty easy solve. X equals -7. I have faith in your ability to do that. Okay, this guy here. So again, I can rewrite these as powers of 2. So that's 2 to the third to the x minus 1. And 4 is 2 squared to the 2x. Okay, and then I can say that this has to equal this. Again, make sure you do that distributive property. So this is going to be 3x minus 3 equals 4x. So then -3 equals x, and we're done. All right, this guy, 25 and 125, those are both powers of 5. So this one I can write as 5 squared to the x plus 3. And this one I can write as 5 to the third to the x minus 1. And again, the reason we can do this is that there's an exponent property. There's a property of exponents that says that you can, when your powers raised to powers, that you can multiply those together. So I'm going to get 2x plus 6 equals 3x minus 3. And again, that's an easy solve. X equals 9. So you see how simple this is? This is why I'm saying it's way easier to do it. If you can write them as powers of the same base, it's easier to do it this way than with a calculator. Because even just getting out a calculator and pushing all the buttons would take longer than what we're doing here. Okay, so 9, that's 3 squared. So that I can write as 3 squared to the x minus 1. And 1/3 is 3 flipped, right? So that's 3 to the -1 to the 5x. So again, setting these exponents equal to each other, I'm going to get 2x minus 2 equals -5x. So let's see. So -2 equals -7x. So x is 2/7. Okay. And then our last guy over here. So 8 and 1/4, those are both powers of 2. 8 is 2 to the third, right? And then what I'm thinking for this guy is I'm trying to start with 2. And how do I go from 2 to 1/4? Well, I have to square it and then I have to flip it, right? So this is going to be 2 to the square it and flip it. So 2 to the -2. Okay. And you always just want to make sure that you get the right number here. This is a spot that tends to trip people up because what I see sometimes is people will look at it and they'll think, oh, well, I take 4 and I square root it and flip it, and they'll write it as the wrong number here. So always just double check, is 2 to the -2 power, does that equal the 1/4 we were originally given? And make sure it's actually true. Okay. And then we can set these guys equal to each other. So I'm going to get 3x plus 3 equals -6x plus 2. So let's see, 9x equals -1, x equals -1/9. And again, I trust you to be able to solve that. That's a pretty easy solve. Two-variable equation. Okay, so not bad, right? So when you're solving, if you can write them as the same, as powers of the same base, it's really not that bad. It's pretty easy and pretty quick to do in your head. Okay, so you always want to make sure that when you're solving equations, you check for that because it'll make your life easier.